Hi everyone, welcome back. In the previous class, we have studied about arithmetic progression and the sum of n terms of an AP. Today, let's see when sum of 3 or more terms of an AP is given, what are the terms to be considered. So whenever the sum of 3 consecutive terms of an AP is given, we have to consider those 3 terms as A minus D, A and A plus D. And whenever 4 terms of the AP is given, we need to consider the 4 terms as A minus 3D, A minus D, A plus D and A plus 3D. When there are 5 terms given, the sum of 5 terms are given, we need to consider it as A minus 2D, A minus D, A plus D and A plus 2D. Let's solve this sum using the previous result. Here the question is given as find 3 numbers of an AP whose sum is 24 and their product is 440. So 3 numbers are given. So 3 numbers means how to consider when the sum of 3 numbers are given. We can consider A minus D, A and A plus D are the 3 terms. That these 3 terms be in AP. So as per the condition, the sum is 24. So when you are adding this, A minus D plus A plus D is equal to 24. Sum of the 3 terms of the AP is 24. So we are considering it as A minus D, A and A plus D. When you are adding plus D as well as minus D get cancels, you will get 3A. 3A is equal to 24. This implies A is equal to 8. So we got the value of A. Now the second condition is given that and their product is 440. That means A minus D into A plus D is equal to 440. Now I'll just write A minus D and A plus D together so that you will get this as A minus D into A plus D into A is equal to 440. Now we know the value of A here, just substitute. So you will get this as 8 minus D into 8 plus D into 8 is equal to 440. Divided by 8, both the sides by 8. This 8 get cancels and this will be 8 5s are 40, again 8 5s are 40, 55. You'll get this value as 55. So this expression changes to 8 minus D into 8 plus D is equal to 55. You are dividing both the sides by 8. You got this as 55. Now this is in the form A minus B into A plus B. It is A square minus B square. Just write this. 8 square minus D square is equal to 55. 64 minus D square is 55. Bring D square to the other side and 55 to this. 64 minus 55 is equal to D square. 64 minus 55 is 9 is equal to D square. This implies D is equal to square root of 9, that is plus or minus 3. So you got the value of D as plus or minus 3. We got the value A as 8 and D as plus or minus 3. Now let's find the 3 terms of the AP. Here we have 2 values, one is plus 3, the second one is minus 3. When D is plus 3, we will get the AP as A minus D. What is A? 8. 8 minus 3, 8 and 8 plus 3 and that is equal to 5, 8 and 11. Now when D is minus 3, you will get this as 8 minus minus 3, 8 and 8 plus minus 3. So that is 8 plus 3 is 11, 8 and 5. So in the reverse order, you will get the other answer. That is all. So this is the required AP. So always remember, whenever the sum of 3 terms of the AP is given, you need to consider the terms as A minus D, A and A plus D. Simplify and find the value of A. Then substitute the value in the next condition and simplify it. You will get the required AP. Consider another question. Find the 3 numbers of an AP whose sum is 15 and the sum of the squares of the extreme terms is 58. Here there's a slight change in the condition. In the previous case it was sum of the numbers as well as the product of the numbers were given, and in this case here the sum is given 15, but the second condition is sum of the squares of the extreme terms is 58. So first let's consider the terms. What are the three terms? Find the three terms. So let a minus d, a and a plus d be the terms of the AP. Now first condition is sum is 15. So when you are adding a minus d plus a plus d is equal to 15. From here you will get the value of a as 5. You are adding this, plus d minus d get cancels, and 3a is equal to 15 and a becomes 5. Now the second condition you have to write. See, look at the second condition. The sum of the squares of the extremes. Here the extreme terms are a minus d as well as a plus d. Sum of the squares of the extreme, that means a minus d the whole square plus a plus d the whole square is equal to 58. Look at that. Sum of the squares of the extremes. See, these are the extreme terms, that is a minus d as well as a plus d, and the square of those two is a minus d the whole square as well as a plus d the whole square, and their sum is equal to 58. Now let's expand this and just substitute the value. That's all. So when you are expanding a minus d the whole square, it will be a square minus 2ad plus d square plus a square plus 2ad plus d square is equal to 58. A minus b the whole square, a plus b the whole square. Minus 2ad and plus 2ad get cancels. The remaining terms will be 2a square plus 2d square is equal to 58. Divide by 2. Get this as a square plus d square is equal to 29. Now substitute the value of a. A is 5. A square is 5 square plus d square is equal to 29. 25 plus d square is 29. D square is equal to 29 minus 25, that is equal to 4. This implies d is equal to square root of 4, and that is same as plus or minus 2. So you got two values for d here. One is plus 2, the other one is minus 2. Now let's find out the terms. A minus d, a plus d, a minus d. So the AP will be, when d is equal to plus 2, the AP is 5 minus 2, 5, 5 plus 2. That is 3, 5, 7. This is the first three terms. When d is minus 2, the AP is 5 minus minus 2, 5, 5 plus minus 2. And that is 5 plus 2 is 7, 5 and 3. These are the terms of the AP. Either 3, 5, 7 or 7, 5, 3 are the terms of the given AP. Consider another question. That's a different type. How many two-digit numbers are divisible by 3? This is what the question. So how to find the numbers which are divisible by 3, and those numbers are only two-digit numbers. First we need to see the two-digit numbers. So the numbers start from 10, 11, etc. It keeps going, and the last number will be 99, and these are the two-digit numbers. Here the condition is given that these numbers should be divisible by 3. So how to find that which are the numbers are divisible by 3? So first you have to consider the starting number 10 divided by 3. So you will get this as 3 3s are 9, and the remainder is 1. Now whatever the remainder you are getting here, that remainder if you subtract from the divisor, and that should be added to the number to get the first number which is divisible by 3. That is a two-digit number. If we consider 10, 10 is not divisible by 3. So we need to find the first two-digit number which is divisible by 3. How can we find that? For that, we have to divide the number, whatever the number we need, the number by 3, and whatever the remainder you are getting, that should be subtracted from the divisor. So when you subtract 1 from 3, you will get this as 2, and this 2 should be added with the dividend. So what you are getting, that will be the number, 2-digit number, which is divisible by 3. If you consider 12, 12 is divisible by 3. 4 3s are 12. But if you consider 10 or 11, these two numbers are not divisible by 3. Now here we are going to make this as an AP, and by using that we can find the number of terms which are divisible. So once again I'll explain how to find this. You have to divide the number by 3, and the remainder what you get, that should be subtracted from the divisor, and whatever you are getting, that will be added to the number to find a 2-digit number which is divisible by 3. So here the first number is 12. The first 2-digit number which is divisible by 3 is 12. So the first number is 12. Now it's very easy to find the next number which is divisible by 3. That means if you add 3 to this number, you get the next number, that is 15. And the next number is 18. It keeps going in that way. Now we need to see the last number. This last 2-digit number is 99, and we have to check whether this is divisible by 3 or not. So the same procedure we have to remember. 99 by 3. If you divide it, 3 3s are 9, 0, again bring the next term, so 9 3 3s are 9, the remainder is 0. So here it's already, this number is divisible by 3. So 99 is the last term. Just imagine you are having some other number, and we need to know whether that is divisible by 3 or not. If you are having 100 here, just think that if you are having 100 here, you will be dividing 100 by 3. So you get the remainder as 1. And in this case, what you need to do is, you need to directly subtract the remainder from the dividend, whatever the dividend is there. So in that way, we can find the last number. Here in this case, that is not required because it's already divisible by 3. So now we got the numbers which are divisible by 3. 12, 15, 18, etc. up to 99. And here now this is an AP, and the last term of the AP is 99. By using the formula of Tn, we can find the number of terms in this particular AP. So what's the general term? Tn is equal to A plus n minus 1 into D, and that is equal to 99. And the value of A, we know what is A here. A is 12 and D is 3. With what number it is divisible, that is the common difference. Just to substitute, you will get this as 12 plus n minus 1 into D is 3 is equal to 99. N minus 1 into 3 is equal to 99 minus 12. And this implies 3 into n minus 1 is equal to 87. Cancel with 3. You'll get this as 2 3s are 6, 27, 3 9s are 27, 29. So n minus 1 is equal to 29, and this implies n is equal to 29 plus 1, and that is 30. So the number of terms of this AP is 30. That means the number of terms, 2-digit numbers which are divisible by 3 are 30. There are 30 2-digit numbers which are divisible by 3. That is your answer. Now these questions are for you. You can solve it and find the answer. In the first question, how many 3-digit numbers are divisible by 87? The same way you need to write the 3-digit numbers, that is, it starts from 100 to 999, and now you need to check the divisibility. Make it in an AP form, then continue the sum in the sum which you have completed previously. And the next question is, the sum of 3 consecutive terms of an AP is 21 and the sum of their squares is 165. Find the terms. Here you need to consider A minus D, A and A plus D are the 3 consecutive terms, and simplify and find the terms of the AP. That's all for today. We'll meet in the next class with a different topic. Thank you.